Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very hard puzzle. And it's called DDDDoppelgänger. I think I might have added one too many D's there. It's supposed to be 4 D's because we have 4D chaos. And it's by Mello Robinson. So Doppelganger. There we go. Doppelganger. Yeah. And here are the rules. We have 4D chaos, where we need to divide the 9x9 grid into 9 orthogonally connected 4D regions. So first of all, let's define what is an orthogonally connected region. So an example of an orthogonally connected region would be something like this. Because you can go in an orthogonally connected region, you can go from any cell in that orthogonally connected region to any other cell in that region just by going through edges, all while staying within the region. So for example, you can go this way to get to this cell here by just going through edges here, and you'll be in that region the whole time. What is not a valid example is something like this, right? Because to get from this cell to any cell in the region would have to be... Actually, I guess we should omit it here. But to get from this cell to any other cell in the region, you have to either go through a corner or go to another region, or go outside the region to get there. And that's not allowed. This also would not be possible as a region, as a valid region, because even though these can get to each other through an edge while staying within the region, they cannot get to the other cells in the region by going through just edges while staying within the region, right? You would either have to go through a corner or you would have to go outside the region to connect. So that's what it means to be orthogonally connected. The digits in a circle indicates how many cells of its 4D regions are in the same 3x3 box as the circle. Okay. So say, let's make this essentially... And all circles are given. Okay, so this, for example, would have to be 2, right? Because the cells that are in its 4D region are 2 specifically in the same 3x3 box, right? Let's say we had a region here. This is not the full region, I guess, but 1, 2, 3, 4, 5, 6, 7. So we need 2 more. You could do this. So say this was also a region. This would then have a value of 3, because that's the same number of cells in the 4D region, which are these 3, which are also in the same 3x3 box as the circle, right? This would be 2 in this case, because this cell has 2 cells which are in the same region as it, in the 4D region as it, as the same 3x3 box. And that's an example of how circles work in this puzzle. We have doppelgangers, where doppelganger Sudoku, where we need to fill each cell of the main 9x9 grid such that every row, column, and 3x3 box and 4D region contain a 0 and 8 different digits from 1 through 9. So that means right. I see. So these are the 4D regions here. Anyways. So in every row, you're going to have a 0 and 8 out of the 9 digits out of 1 through 9. And you're going to be having a missing digit in every row column and 3x3 box and 4D region. No 2 rows, no 2 columns, and no 2 3x3 boxes, and no 2 4D regions may be missing the same digit. So, for example, say we were missing a 5 in row 1. Then none of the other rows could be missing a 5. Because, again, no 2 rows can be missing the same digit. No 2 columns can be missing the same digit. No 2 boxes, 3x3 or designated 9-cell regions can be missing the same digit. And no 2 4D regions may be missing the same digit. And in addition, for each 0 in the grid, the digits missing in its row, column, 3x3 box, and 4D region must be 4 different digits. So for example, say we had a 0 here, and we're missing a 5 in row 1, which is the row that 0 is in. You cannot be missing a 5 in the same box, in the same column, or in the same 4D region. I don't know how we designate which one's which, but okay. So you could not have a 5 missing in column 1 and then a 5 missing in column 5 if this were the 0, right? Because it would be missing a 5 in its column and a 5 in its row, which is not allowed. They have to be different digits that it's missing. So that's how doppelganger works. We have arrows, where a digit n in a cell with an arrow points to a cell n steps away within the 9x9 grid that contains the digit missing from the 4D region that the arrow is in. Not all arrows are given. Okay, so for one thing that is important is the digit in the circle indicates how many cells of its 4D region are in the same 3x3 box as the circle. All circles are given is a negative constraint. So keep that in mind. I have to do this to remind myself too, actually, because I forgot about one negative constraint in a very hard puzzle because it took so long to do it that basically I came up with multiple solutions, and then after reading the comments, I realized, oh, I completely forgot about the negative constraint, which I had identified at the very beginning of the puzzle because it had taken so long to solve. So keep that in mind. That all circles are given for the 4D chaos. However, that is not the case with arrows. Not all arrows are given, but the digit n in a cell with an arrow points to a cell n steps away. So say we had, this is an arrow. Actually, let's use the one we already have. Well, obviously that's going to be, well, that's not true. So we could have something like, say, a 4 and a, well, can't have 5. We could have a 6 and a 7 here. So 6, wait, that doesn't, yes, that does work. 1, 2. So that means that digit, say we were missing an 8 in the orange 4D region. That would mean we have, this arrow would have to be 1, 2, 3, 4, 5, 6 away from this cell. So 1, 2, 3, 4, 5, 6. So that would mean that 8 would have to be here if we're missing 8 in the orange region. And that would satisfy this cell too, because 7 away from that cell is 1, 2, 3, 4, 5, 6, 7, and it's the same cell, which is 8, which is supposedly missing from the orange region. And that's how arrows work, right? But not all arrows are given. I hope that was clear. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so I think the interesting part of this, can arrows be 0? And the answer, I believe, is no. right? So if it's 0 steps away from its region, it's going to be its own 0. First of all, 0 can never be missing from a region, any region or any row or any column or 4D region. So because of that, then none of the arrows can ever be 0. And they have to be, obviously, it has to be part of the 9x9 grid. So it's however far away it is, right? So this cell can be 1 away, 2 away, 3 away, 4 away, 5 away, 6 away, 7 away. But it can't be 1 or 6 because of 1 or 6 in the row. So this could be 1, 2, 3, 4, 5, 6, 7. So this could be up to 7 away. What about these two? Let's color these. We'll go around. Blue, yellow, red, green. Oops. How did I get both? Green, light, medium, dark, orange, and pink. Those are the 4D regions that we have to decipher what missing digit is in those digits. So this is 7, up to 7. This is up to 8, right? 1, 2, 3, 4, 5, 6, 7, 8. But it can't be 8, though. If it were 8, that would say that in its region, 8 is missing. Which obviously, having an 8 in that cell is not possible. So this is 7 at most. Also, can this be 5? It's the same problem with 5. So these digits can't be 1 or 6. So it's 2, 3, 4, 5 up to 7. But this one can't be 5 specifically because it's saying 1, 2, 3, 4, 5 cells away is the digit that's missing in its region, but it already has a 5 there. So it can't be 5. This could be 2, 3, 4, 5, or 7. This is up to 7 also. Oh, these can't be 4. That's interesting too. Because of 4 in the box. This is 1 through 8 also, but it can't be 8, 1, or 4. So 2, 3, 5, 6, or 7. Same with this, but this could be, this is 1 through 7. But no 4. This is 1, 2, or 3, and it cannot be 1, so this is 2 or 3 cells away. This is 1, 2, 3, 4, 5. Could be up to 5. But it can't be 1 or 5 because of 1 in the box and 5 in the row. This is 1 or 2. So this is 1 or 2. Pointing at one of the cells that it's not in this region. This is, again, as I said, up to 7. This is up to 8, but it can't be 8 here. So these are both up to 7, actually. 1 through 7. No 5 available. No 6 available here. Okay. This cannot be 2 away, because for its region... Oh, these have to be separate regions too, right? If this were the same region, they would have the same amount of digits in the 4D region as the 3x3 box. So yeah, they have to be different regions. So this is a border. We need to use edge only. So this we're going to make either light or green. Let's make it light for now. And it has to go down here. And this must be a different one. We'll make it medium gray. It could be light here and then green here. We could potentially do that also. This cell, though, has to have at least 3 digits that are in the same region as it, because otherwise it can't get out of the box. So this cannot be 2. So this is 3 or 7. So 3 away would imply that this has to be 2. That's interesting. Hmm. This cannot be 7, because if this were 7, it would block the light region from getting out altogether, right? It would have to be all of this is the same region. So this cannot be 7. It's 2, 3, or 5. These digits can be up to 9. So 2, 3, 4, 5, 7, or 9. This is not 1, not 5, 2, 3, 4, 6, 7, 8, 9. And this is up to 9 with no 8. Ugh, that's a lot. Okay. All circles are given. So 1 cannot be here. This can't be 3. If this were 3, that means 3 cells would be in this region. This would have to be 7, though, which would mean 7 cells would have to be part of that region, which can't work. So this cannot be 3. Therefore, this is 2 or 5. If this is 7, this has to be 2. If this is 3, this has to be 5. Okay. So that means most of these are going to be... So if this is 3... So if this is... Okay, this is 3. It has to go 3 and then out. So this is part of the light region. If this is 7, then all 7 of... This has to be 2 and go out, and all of these must be light. So we know this is light. If this is 3, this could still be 2. So 4 is part of this light region. 3 or 7 is the digit that's not in the region. So, interestingly enough, Okay. We need a 0, obviously, so... One of these 3 is a 0. So what happens if this is... Okay, if this is 7... So the missing digit in light is never going to be 4. So these are the key cells for this region. So if this is 3, this could be 2 or 5. Oh, this can't be 2. If this is 2, that means there are only 2 cells in that region which are part of the same 40 region. 2 cells in the box which are part of the same 40 region. So it must be 2 here and it must go out here. But then this is saying that this cell, 2 cells away, is the cell that's missing in this cell here. So this cannot be 2. This must be 5. And this can't be 7 anymore, so this must be 3. So 5 cells in this region are... well, okay, so then we'll make this green, because it has to go out there, and this is going to be light. So this must go out here. It goes out to there. This is green. 5 of the cells in box 1 are light, and so we can't have 3 and 5 here. So 5 cells away is 1, 2, 3, 4. 1, 2, 3, 4, 5, which is a 1. So 1 cannot be in the light region. So this is 2, 6, or 7 away. 5 out of these cells are light. We don't know which ones. I think actually this has to be light. If we try to make these 5s, this doesn't have a region, because this only has 3 cells which are in the green region. So this must be light. And we don't, so this cannot have a 1. So this must be 2, 6, or 7 away. This is 2, 6, or 7 away, and this is 3. So we cannot be missing a 3 in the green region because we already have a 3. So this must be 2 here. So this is 2, which means this cell is missing from that region, whichever it is. Obviously, 8 is not a 2. So we're missing in the green region a 2. So this cannot be 2 in the green region. This must be 6 or 7 away. The 5 is missing a 1. So it cannot be 2 this way, because there'd be 1, 2, and that would force a 1 to be there, but we already have a 1 in the box. So this must be 6 or 7. So 1, 2, 3, 4, 5, 6 or 7 away is the 1. So this is guaranteed to have a 1 here, which means this can't be 1, this is 2, this can't be 2, this is 3 or 4. So 2 away going this way is the cell that's missing, or the digit that's missing from this region. So 3 is, the green region is missing a 2. The light region is missing a 5. Okay. Green cannot go all the way down here, because then the green region would be missing the same digit as column 1. And the 0 in that region wouldn't be missing the same digit. And that's not possible. Okay. 2 is there. 2 is here. This can't be 2 because of 2 in the row. So 2 here is 6 away. 1, 2. So this can't be 6 or 7 because of cells in the row. So 6 away. 1, 2, 3, 4, 5, 6. Or 7 away. So 2 has to be one of these 2 digits here. 2 away is here. This has 5 cells. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that could be light there. What are the remaining digits in box 1? We have 0, 1, 0, 1, 2, and 9. Interesting. This can't be 2. This can't be 1. Okay. The interesting thing if this is 2 is that it has to be 2 and then go out, right? Almost immediately. What are the remaining digits in row 2? We have 0, 0, 1, 0, 1 through 5, 0 through 5, and 9. And 9. Obviously this can't be 1, this can't be 1, the rest of the row cannot be 2, this can't be 5, and that's all we have restrained. I'm gonna get a cop drop because, I don't know. Maybe I'll clear some stuff up. So this digit is a digit missing from that region. This digit is the digit that's missing from that region. 3 or 4 away, so one of these two digits is the digit that's missing from that region. Oh, interesting. So the light region is missing. Oh, this is not missing a 5. It's missing 1. Right. So 3 away. That's a digit that's missing in the 40 region. So green is missing 2. 5 away. 1, 2, 3, 4, 5 is missing a 1. So if it's part of the light region here, it would be missing a 1. So 1 could not be in this row or in this box. Or in the light region. But if it's not part of the light region, then that cell would be the only cell in that region, in that 3x3 box of that region, and would therefore have to have a circle around it, right? So say these were the 5 light cells, and this was a 1. Then this cell would have to be part of another region, and it would be the only cell in that box which is part of that region, which would mean it would have to have a circle on it, and all circles are given. So neither of these can be 1 then, which makes this a 0, 2, 9 triplet. Which means we're missing 1 in that region. Or sorry, in that box. Well, we're missing 1 in the box. We must be missing... That 0 in the box is missing that 1. So it cannot be also missing a 1 in the 4D region, which is light region. So the 0 here has to have a... has to be from a different region. Okay. 2 away is missing this cell. So that could be part of the light region also. No, because the light region contains 2 and 9, guaranteed, right? 0 is the digit that's missing from the light region in box 1. Because again, the 0 in the light region would be missing a 1, and the 0 in the box would be missing a 1, which is not allowed by the rules. So the light region contains 2 and 9, guaranteed. So this cannot be light. So this, whatever region this is part of, it's not part of light. So it's not part of green either. So this can't be missing a 1 here. So this can't be 1 there. This cannot be part of the light region either. So these are different regions. It cannot be green and medium. You can't have a 0 here because no region is missing a 0. This cannot be green because if it were green, 4 away would be the digit that it's missing, right? Because it can't be. 3 and 4 are both here. So this can't be green. These could be the same region. This could be a different region than this, but it has to be a different region than that, but could be the same region as that. The circles can never be 9. If they are 9, the 0 in it, in that region, is missing the same digit as the 40 region. Or sorry, as the 3x3 box that it's in, right? So that's why this can't be 9. This can't be 9. This can't be 9. It can't be 2 because of 2 in the row. Huh. Okay. Possible digits missing from row 1. 2, 4, 7, 8, 9. Okay. Hmm. Not sure where to tack now. Hmm. Okay. Missing in column 1. Excuse me. 2, 5, 6, 7, 8, 9. Hmm. Huh. I think we have to approach this one because this is the one that's the least it's the most potentially restrictive, right? 2 being here isn't really that restrictive. Hmm. Huh. Hmm. Well, we know green cannot go to here, green cannot go to here. You could have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't actually have to go beyond this. It does have to enter, though, here or here guaranteed. Because there's no other greens in box 1. It can't be part of 2 because it's missing a 2. And it can't be 3 or 4. So it can't go to here, can't go to here. it has to go either here, exit out either here, or just basically be 6 here, right? 6 here or 6 this way. But it must enter one of these at least. We don't know which. Hmm. So we're guaranteed a 2 has to be one of these 2 digits here. Oh, the 8 has to be part of this light region. If it's not, then you'd have 0 again, missing a 1 in the light region and a 1 in the box, which is not allowed. So this must be light. But it still could be any of them, right? Hmm. Um. Hmm. Hmm. Um. Huh. Huh. I'm not sure where to attack this then. Huh. So that means the light region is missing a 1. We have 5 guaranteed here. Light can only get to here or 1, 2, 3, 4 here to be missing that 1. Which means we could have the 1 missing in rows 1 through 7. Cannot be 1 or 7 though, so 1 has to be missing in one of those 5 columns. And same with up to row 7. But obviously this can't be missing a 1 because of the 1 in the row already. Interesting. Um. Hmm. What else are we missing? Okay, column 2 is missing 1, 3, 4, 6, 7, 8, 9. Column 3 is missing 1, 3, 4, 5, 6, 7, or 9. And this is because we have a 2 here, and we guaranteed have a 2 there. Hmm. If the green were all in this cell here, so say it was like that, or like this, then 6 could not be in this region, which would mean 6 in the green region would have to be here. So that would force us to be 7 and 1. And 6 away from here would be 2 here. So this would not be 2, which is very possibly likely. And the reason why we know that is we would have 6 cells in this region, which are part of the green region and also part of the same 3x3 box. So 6 could not be part of that because then it would have a circle around it. What else do we have? Yeah, I mean, the problem is I don't really know where to tackle this, right? We either tackle the chaos construction, the circles, the arrows, but the problem is it's kind of wide open after that, right? Or the doppelganger part. Um, okay, one interesting aspect of the green. So green cannot be part of box 1 anymore. It can't be the 3 or 4, it cannot be 2. So green could do something like that if this were 0. Okay. Okay, that's interesting. So it cannot go this way. If we try to do it this way, first of all, one of these would be 0. And on top of that, if 0 here, it could not be missing a 2 in the same column, but it would be missing a 2 in that column because green would be all the way over here, and this can't be 2 because of 2 in the box. So it would be missing a 2 in that column and in the green region. But if we had a 0 here, this would be missing a 2 in... Yes, none of these would be 0, and this would be 0 here. And you'd have 2 zeros in the same box, which is not allowed. So green cannot go full here. I don't even know if it can go to there. Well, maybe. Possibly. Oh. Okay. Where can 2 be in column 1? Can't be here because 2 in the box. Can't be here because of the filled out stuff. It could only be one of these 2 if there is a 2. if green is wholly in this box, in box 4, you have to have that 0 in the green region has to also have a 2 in its box, because it doesn't have a 2 in its 4D region. So this would have to be a 2 in that case, if it were fully contained in this box. It could exit out this way, and then this could be 0. Well, okay. Okay, so say we try to have this go all the way down to here. This could not be the 0. Right? So, okay, we know... So I think... So we know we can't go this as a green region, because then there would be no 0. Either 0 would be here, but it would be missing a 2 in the column and the region, in the green region, or the 0 would be here, which would mean none of these are 0, which means we need a 0 in column 1. It would have to be here. So that doesn't work fully as a green region. What about if we had green here and green as one of these two? That doesn't work. Because then 2 couldn't be in its column, because, right, if, say, we had a 0 here. If we had a 0 here in the green region, then column, because all of these are green, there's no 2 in them, and this can't be 2 because of 2 in that box. So this can't. So therefore, 2 would be missing in column 1, and the 0 would be missing a 2 in the green region, which is not allowed. Well, if we try to make it here, none of these can be. This can't be 2 because of the 2 in one of these two cells, and it can't be 2 here because of the 2 here, and it can't be 2 here because of the 2 in. Q can't be in the green region. So then this 0 would be missing a 2 in the box and 2 in the green region, which is not allowed. So you have the same problem here, I think, right? If this is 7 this way, and you go 3 here, or you go 7 this way, you have 2 more here, or 2 there, or 2 there, or whatever. 0 can't be in these cells because we're missing a 2 in the box, because this can't be 2, this can't be 2, and this can't be 2 because of the green region is missing a 2. And then these can't be 0 for the same reason, right? Any 0 here, well, you're missing a 2 in the column guaranteed, so you're missing a 0 in green and a 2 in the column. So I think that also... So that does not go for this one, because if it goes this, it could exit out. And then this could be a 0 here. Right. But then we have a problem there. So if we tried to do this and then out here, this would have to be the 0, because any 0 here would be missing a 2 in the box. If we had just 1 out here going this way, this would guarantee have a 5 in the region, because the green has to have a 5 in the region because it's missing a 2 only, and this can't be 5. So 5 would have to be here, and it would have to have a circle around it. So green cannot go here. Green definitely has to get to here. So this is definitely green. So the question is, where are the other cells, right? Right, and that was the reason, because we can't have 5 there. We could have 4 cells here. We could have a full 6 here. We could do, yeah, this is at least 4 in this region. Can you ever have 5 in this region? I don't think so. Right? If you have 5 in this region, I don't even know how that works. Five, I guess it could be 5 if this is the 5, right? So it goes 1, 2, 3, 4, 5, and then this is the 5 because it doesn't. We can't have a circle of 5. Um. Huh. But what happens if we have that as 5? So say it was that. Then this 2 away would not be... Okay, so that could be fine. We could have something like that. That would seem to work. Huh. Okay. So the possibilities are there are 4 cells in this region, there are 5 cells in the green region in box 4, and there are 6 cells in the green region. The 5 cells is that it has to go down here. I guess it could do something like that. That's also possible, right? So it could do that. It could be doing that for 5. For 4, it could just basically get out. It would have to get out this way. For 6, that would mean that this has to be a 6 because we can't have a 6 here because there would be a circle in it. Huh. Oh, this can't be missing a 1 because, oh. Okay. There has to be, right, so this is using the doppelganger. Since we're missing a 1 in box 1, the 1 in the whole grid has to be missing in rows 1, 2, or 3, or has to be in 1, 2, or 3, and columns 1, 2, and 3, because it's missing in box 1, right? So that means there is only 2 ones total in those columns, right? Because you can't have more than 1 1 for each of the rest of the boxes. That's two ones in total. So this has to be missing a 1 here. And these cannot be missing 1s. Same here. We're missing a 1 in one of those cells, so this can't be missing a 1. Ah, so where is the 0 in box 1? If it were 0 here, it would be here, it would be missing a 1 in the box and a 1 in the column. So 0 cannot be either of these. Therefore, this is 0. Which means this cannot be 0 here. And no 0 here. And obviously this can't be 2. So this is 2, 9 as a pair. This is 0. Ah, this has to go out. So these are all light. This is a boundary. It has to form a boundary here. So this has to go out. And we'll make this pink then. So this is pink. Green then has to go here. And again, it cannot be here because then this would have to, this cannot be 5. 0 would have to be here. Would have to be specifically be here because it would be missing a 2 in that cell. Interesting. So whatever digit's missing in pink is 3, 4, 5, or 9. Um, so this is at most 5, and it could be 4 in this region. So again, you could have 5 going. Okay, so this is definitely a border. Hmm. Remaining digits of the green region. We have 0. No 1, no 2, no 3, no 4, 5 through 9. And this can't be 0, 5, no 8 here. No 9 here. Interesting. So either it goes down here as a 5, and then you have a 0 here. Or it could go 3 here. Or it could go 3 here, 3 here, potentially. Hmm. Pink cannot be just 2. You could just go there, though. That is possible. So this still could be 8. Actually, no, it can't be 8. If this were 8, so it could be part of pink, but if it's part of pink, then it has 6 cells in the same region as the box. If it's not, if we try to make it 8, it's not part of pink. But then the 0 in the box would have to be missing. So pink is not missing 2. So whatever is the rest of this box would be missing the same as the region if this were 8, which is not allowed. So this cannot be 8. Could very well be 5. I think this one, well, one of these is a 5 if it goes out this way. I guess this could be 5, though. Yeah, so this could be 5 also. Hmm. You could have a 0 here, and then this be 2. That would guarantee this is not 7. I don't know if that helps much. We have 1, 2, 3, 4, 5, 6, 7 greens. It could be green, green, and then this is, again, this is 5 here, because 5 can't be in the green here because it would have a circle around it. Oh, no, it cannot be green. Well, actually, okay. Green makes it very interesting. None of these could be 5, so where's the 5 in the green region here? So it has to be 5 here. Therefore, 0 would have to be here. It could not be, it would be missing a 2 in the green region, so it could not be missing a 2 in box 4. So this would be 2. And then these would be 2 separate regions then. I guess that could work. So this would have to be, make this red, and this would be yellow. Red would have to continue out here. So 1, 2, 3, 4, 5, 6, 7, 8. Yellow, though, could expand to a lot of places. Obviously, this can't be 5. No 5 here. And this couldn't be the same region as this, because then that would be 2 cells of red in that box 4. And there would have to be a circle around there, which there isn't. That's the reason why this is just 1. Okay. This would have to have a 0 in it. Obviously, this could not be 2. This could not be missing a 2, so it would not be 7. This would be done as a region. So whatever digit's here would be the one that's missing from yellow. Okay. This couldn't be 0. This would be 0, 6, 7, 8, 9. We don't know which. Huh. So we would not be missing a 2 here. We'd have to have 0, 6, 7, 8, 9. 0. We'd be missing a 5 here. So we'd be missing a 5 in this column. 0, 6, 7, 8, 9. Because it cannot be 5 because of 5 in the box. So far, this is looking kosher, which is not great. Huh. Hmm. I mean, it's looking fine. No 8 there. Remaining digits of column 3. We have to have 0, 3. 0, 3. 4, 5, 6, 7. And obviously this can't be 0 because of 0 in the region. This can't be 5 because of 5 in the row. But these are not restricted. Huh. So 2 could be missing. Oh, where is 2 missing? 2 is missing from the green region. Okay, that's why that can't work. So say we have 2 go here. So this would, the only way it's missing 5 from this green, assuming it goes, sorry, the only way that there is 5 cells that are green in box 4 is if it goes this way. And then it would have to go out this way because it needs a 5 somewhere in the green region. But say we tried to do that. If we tried to do that, this would then be 5. These would not be 3 or 4. We not have 5 here. This would not be 5 here. This would be 0, 6, 7. We have a 0, 6, 7. Well, that doesn't matter. The problem is there's a 0 here, and it cannot be missing a 2 in that box because we're already missing a 2 in the green region. But where's the 2 missing in the columns? It has to be related to the green region. Since we're missing a 2 guaranteed in the green region, we cannot be missing it in any of the other regions. And the green region doesn't extend beyond columns 1, 2, and 3 in this scenario. And we can't have... the problem is 2 cannot be missing in... we can't have a 2 missing there either. But the problem is we can't have a 2 be here. Because we have to have a 2 missing in the columns. And because of the way that, since it's only missing from the green region, that's the only place it could be missing then for the columns. Every other region would have to have a 2 somewhere in these columns. And since none of these are the 2 that are missing, then in that case, then it's not possible for it to go there. So this can't be 2. So this must be 4 cells, because if we try to have 5 in this region, and it has to go out this way. So this must be going out here. So this is green. Okay. So this is boundary. This is obviously boundary. Can this be 7 anymore? The answer is no, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 5, 6, 7, 8, and then one of these is green. Which means this can't be 7. So it could be 6 still. If it's part of pink, that could work. We do not have a 5 here. So 5 has to be one of these 2 digits in the green, which means we cannot have 5 in the rest of the box. So we're not missing a 2 in box 5. So where are we missing a 2 in the entire grid? Again, it has to be part of the green region. That means we must be missing a 2 in box 4. Which means the 0 cannot be in box 4. It has to be in the green region in box 5. So we're missing a 2 in box 4. Therefore, in column 1, you have to be missing a 2. Right? Because we can't be missing a 2 in columns 2 or column 3, and it has to be part of where the green is to be missing a 2. So this is definitely 5. This is 0. No 5. 6, 7, 8, and 9. And, well, we don't know what these are. These could be anything. But 0 is guaranteed to be one of these 3 cells. Pink is interesting. Can you do 2 here and then go around is kind of the question. And the answer is no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it cannot be 2. It could just be part of all of this, right? It could be 3, it could be 4, or it could be 6, right? That could be the case. We're missing 3, 4, 6, 7, 8, 9 in this box 5. So we have to be missing a 2 in either column 5 or column 6. Sorry, row 5 or row 6. Because it's wherever this 0 is not, interestingly enough. So we can't have a 2 here or a 2 here, which means there must be a 2 in one of these cells here. And it must be opposite of it has to be in the same row as the green 0. Oh, well, where's a 0 in box 4. It must be one of these two cells because it can't be in the green, can't be in the pink. It has to be one of these two, which means this cannot be 0 here, so we're guaranteed a 0 for the green in row 5. That means that 0 cannot be missing a 2 in its row, so this is not missing a 2. This has to be missing a 2 in row 6, which matches... Wait, nope, that doesn't work. Oh, that's bad. That's bad. Oh, that's not good. Okay, what did I miss? Oh. I think this is still correct. Oh, wait, we don't have to be missing a 2 here. We could be missing a 2 in column 5. Right, that is where, and that's where we, yeah. So then we do reach a contradiction if we don't have a 2 here. So we know 0 in box 4 has to now be one of these two. Because it cannot be here, because it would be missing a 2. Wait. Okay. If we assume it's missing a 2 in box 4, then one of these is, well, right. Okay. That's interesting. Fascinating. Yes, this still has to be 5. That's still correct. But we are making the assumption that 0 could not be here because 2 must be missing there. This is not necessarily the case, but let's assume 2 is missing in column 1. If 2 is missing in column 1, that's a very easy assumption to make because, right, that just makes that not 2. That means we must be missing a 2 specifically in box 4. Which means the green 0 cannot be in box 4. It must be in box 5. And therefore, where is the 0 in box 4? It must be one of these two cells. Well, since 2 is missing in box 4, we're missing it in rows 4 through 6. And obviously, we're not missing it in row 4, so it must be missing in 5 or 6. Well, the 0's here means this can't be 0, which means one of these two is 0 for the green. The green, then, this 0 would either be... So if 2 were here, this 0 would be missing a 2 in the region and a 2 in the row. If this were 0... Sorry, if 2 were here, this 0 would be missing a 2 in the box and the 2 in the row. Hence, this assumption is incorrect. So we cannot be missing a 2 in column 1. So, where is the 2 then? It can only be here. So this is 2 here, which means we're missing. So we have to go green. None of these can be 0. Actually, these could be 0. But we have to be missing a 2 in a column here. Well, it has to be a column which contains a green, so it must be the last possible green here. And therefore, this is done as a region. And 0 could be is any of these, but it cannot be missing a 2. So 0 has to be one of these 4 cells in green, so we cannot be missing a 2 here. So these are not missing 2's, which means 2 has to be missing either here or in here. Or this, I guess. Yeah. 2 must be missing in column 5. That's interesting. Because it must be missing in a column where blue... Okay, so then 2 has to be missing in rows 1 or 3. This cannot be missing a 2 here, right? So we have this as 0, 5, 6, 7, 8, and 9. So here we are guaranteed 8 and 9 and 5 here, and this can't be 5. So this cannot be missing. It cannot be missing 5, 8, or 9. So we're missing, and it can't be missing a 2. So we're guaranteed a 2 can't be here. 2 has to be one of these 3 digits here. Which means we're missing in row 5 a 1, a 3, a 4, or 6, 7. Okay. Interesting. Where is 0 then? Well, we don't know. It could be either one of these two or this one. This region cannot be 7 away. That its cells missing. 1, 2, because 1, 2, 3, 4, 5, 6, 7 would be missing a 2, but we already have a region missing a 2 in the green region. So this can't be 7. So this cannot be. It can be 1, 3, 4, 6, 7, and 2's here. This can't be 1, though. This can't be 6 because of 1s and 6s in the column. So this is either just 1 or it's part of the circle. It can't just be 2. It can't not contain 2 digits here and then get out because and not be part of the circle because it doesn't have enough cells to extend to that to more than 2 if that were the case. This is 5. This digit here, no 0, 1, 2. It could be 3, 4, no 5, 6, 7, 8, and 9. Okay, so that's still pretty broad. Okay. So we must be missing a 2. So we're missing a 2 in rows 1 and 3 and in column 5. That means we're missing a 2 in box 2. Because that's the only one that fits the criteria of rows 1 and 3 and column 5. So we're missing a 2 here. Interesting. So remaining digits are missing could be in box 3 as 3, 4, 5, 7, 8, and oops. These are all possibilities. 3, 4, 5, 7, 8, 9. So this cannot be 2 and then go out. It could be... well, that's interesting. It could be 3. No, it could be just 3 here. I was going to say that this has to be part of that region. Well, okay, so if pink is part of this, well, it could be... no, it cannot be a separate region. Okay, so these two have to be part of the same region, whether it's part of pink or another region. And the reason why you know that is, say it wasn't part of that region. It would be part of the pink, but then the pink would have two cells, and this would have to be a circle. So it would have to be a separate region, but we know this two away is not part of its region. So the pink region, if this is not part of it, would have to go like that, and then this would be blocked from having a region. So no matter what, this is part of this region here, definitely. But we don't know what part, right? It could be part of pink. It could be its own separate region. That could be the case too. Um, hmm. You cannot have a 0 here. If this was 0, it'd be missing a 2 in the column and a 2 in the 4D region. So no 0 here. So either this is 0 or one of these two is 0. I'm kind of inclined to say that these would be 0, but I'm not sure. Right? Um, hmm. Yep, this is definitely a very hard puzzle. um, let's see. If we go that way. Well, this could be a full 6. Assuming it's there, right? Um, remaining digits in row 1. We have 0, 2, 4, 7, 8, 9. Right, this can't be 2. Oh, none of these can be 2. Because of the 2's missing in box 2. Hmm. Oh yeah, and a continuation of this, even if this were pink and this was not part of the region, the problem is you would go around and then this would not be part of a region. So that's why these two are always part of the same region. We just don't know which. Oh, we can't be missing a 1 here. If we were missing a 1 here, that wouldn't work because we're missing a 1 in box 1. Um, Interesting. Where is 1 in box 5? It has to be one of these 3. And then the 1 in box 6 must be one of these 4. That doesn't really help us much, though. Uh, hmm. Hmm. What about the light region? Hmm. What happens if this is a separate region? That's interesting, actually. So then pink definitely has to go these two, if that's the case. Orange has to be at least 3, and it can't go around, it would be blocking, so it must connect to that. We'd have 1, 2, 3, 4, 5, 6. Obviously, we need 4 more for the lights. It cannot go there. Oh, that's a little problematic. We need 4 in the light region, and this can't be 4. Huh. I guess it could do something like that. And then this would be 4 here and 3 here. Right, so this light has to exit out. Interesting. Okay. So that's the next step. Where is light? Light has 4 cells left. It cannot all be part of box 2. But it can't even connect to here because then that would block the pink region, right? So it can't, I don't even think, well, yeah, it can't exit out this way because it would block the pink region. It could do something like 1, 2, 3, 4, though. Or 1, 2, 3, 4. And I guess it would have to because we are guaranteed a 4 in the light region. And if they were all in box 2, that would be a fail. So we have to have the light go 4 here or 4 here, guaranteed. It's one of those two. Because it can't go 4 here because it can't include the 1 because of the way that the arrow works. And it cannot go 3 here and then down, or 2 here and then down because that would block the pink. So it's either 4 here or 4 here, which means one of those digits is a 3 remaining because the light also needs a 3, and this is guaranteed to have 3 in box 2. So 3 cannot appear in these cells, so 3 has to be in the cell that's outside. So 3 has to be one of these two, which eliminates 3 in the rest of the box, and eliminates 3 from being the one that's missing. So if we did this is all the same region, that's fascinating. If we did all of this was the same light region, we would guarantee no 3 here, because there would have to be a circle around it. And 3 would have to be one of these 3. But the problem with that is, how would you break it up? I guess it could be 1, 2, 3, 4, 5, 6, 7, 8, 9. That could work, and then you have a 3 or 3 would be part of that, right? Could be part of that, and then you have a separate one out there. So that does kind of work. Huh. We are guaranteed a 6 has to be one of these 3. That's interesting. Because we're missing only a 2 in box 2. So 6 has to be somewhere, so 6 would have to be one of those 3. We know 3 has to be some of these sets. Uh, uh. Interesting. So if this is all light, that's interesting. I guess 2 still could be there. Yeah. This would not have a 3. This would have to be a 3. This would then be 4 here. Okay, so we're guaranteed. Oh, light needs a 4. And light cannot have a 4 if it goes all 4 there. So this does have to be all 4 here. Yes, so light needs a 4. Again, if all 4 were in box 2, we'd have to have a circle around it, and there's no circle. So it has to extend out, so it must be 3. If we try to go 3 and 1 here, pink is blocked as a region. So it has to go all 4 out here. So this is guaranteed then. This has to be the region. So we now are missing a 3 in the light region. They cannot be here. So it must be not here. And we can't have a 9 or a 1 in the light region. And we can't have a 5 anymore in the light region. So this must be a 4. Which makes this... Hold up, we have a problem. Ooh. How does that work then? Oh. Oh no. That's problematic. Huh. We need access to a 4 for the light region. Oh boy. But we're running into problems now. Because of the 6-7 pair here. Uh-oh. Okay. Might have to come back to this one because... Yeah. We have problems here. We need 4 cells. But we need a 6 and 7 too. And it cannot be 4 cells this way. It can't... not good. Not good. I might have to come back to this with a fresh start in mind because I'm not... Again, cannot go down here. It's 5 cells here. We cannot go 4 there because that's a 1. 5, and we know that digit's missing. So I can't do something like that because that's 4 cells, which require 4. Can't go like that because there's not enough digits here. We're missing a 6-7 also, so we need a 6-7. But we can't do that. We can't do that. We can't go here. We can't go all 4 here because we're missing a 4 then. Oh. So that means some of my logic somewhere before is missing. Maybe it's this part. I don't think so. Yeah, because there has to be a 1 somewhere here. So then that forces that to be 2. which is mean this can't be 2. And this couldn't be 2 anyways. This is 3, 5, so that removes 3, 4, 5 as a possibility. 1 obviously can't be here because of 1 in the column, and this can't be, the light is missing a 1. I'm not, yes, I'm not sure where I messed up. This is going to be problematic. We're missing a 6, 7 also. So we're missing a 3 in the light. We're missing a 3, we're missing a 6, 7, we're missing a 4. And obviously a 0. Um, huh. Yeah, I don't know if I'll be able to figure out where I messed up here. I think I'm gonna have to basically start from scratch in another video. I've got the logic of it a little better. So I've done a decent amount of doppelgangers, but I think I've started into it a decent amount of what things have to be where. But the problem is that I made a mistake somewhere, and I don't know where it is. Uh, I think I think all this logic made sense, but maybe it doesn't. Hmm. And the problem is I don't know where to attack it, because I don't know if it's regarding the light region, or if it's part of the green, or if maybe it's something with the pink or orange. Uh, I mean, the problem is that basically the light has to not include a 4 here, but it has to have a 4 somewhere here. And it has to be 5. Could it be 2? No, because again, if it's 2, it gets blocked out that way, so it has to be 5. Yeah, I think all of that is still kosher. It might be something with the green, or it might be something with the pink. That would be my guess. But the problem is I don't know where exactly, and I think I have to start off at the beginning again to make sure I don't make the same mistake, right? Or I basically. And I don't know if I have the willpower to do that right now. So, or the brain power. My mind's a little frazzled by that. Okay. Well, I guess I'll see you guys in the next video then. I think I've gotten a good start on this and have a good feeling for how doppelgangers work, but I made a boo-boo somewhere, and I have to figure out where that is. But I don't think my brain right now is currently in the state where it can find that easily. So I will shelve this for now, and I'll see you in the next video with hopefully the doppelganger puzzle. Take care.